Newton's first law of motion. Motion is the change in an object's position. Isaac Newton, an English scientist, proposed 3 laws of motion that help us understand how objects behave when they are at rest, when they move, or when force acts upon them. The first law says that an object that is stationary tends to stay at rest, and an object that is moving tends to keep moving until a force acts on it. Let's see how this law works. Let's consider a stationary rubber ball resting on a table. The ball is not in motion, and it's said to be in a state of rest. If we leave the ball there, it will continue to be at rest. In fact, an object such as a table, the cabinet, and the book will remain stationary for any length of time. The law also says that an object will stay at rest until a force acts on them. To a resting ball, if we use a small amount of force to push it, it will move from its original position. The force created by a gentle push has set the ball in motion, meaning force has changed the state of rest of the ball. Now, let's have the second part of the law. The ball will continue to roll for some distance, gradually slow down, and eventually stop. According to the law, an object in motion will continue to be in motion until a force acts on it. In this case, friction, a force that opposes motion, has stopped the motion of the ball. Let's see another force that changes the movement of the ball. Let's roll the ball and keep a book in an angle of its spot. The ball strikes the book and rolls away in another direction. In this case, the book is the force that has changed the direction of the moving ball, which would have continued to move in its original direction. Newton's second law of motion. This law tells us that an object's acceleration depends on its mass and the amount of force acting on it. It says that the acceleration of an object is directly proportional to the net force on it and inversely proportional to the mass of the object. Let's try to understand this in much simpler terms. If we increase the force on an object, its acceleration will increase, but as an object's mass increases, its acceleration will decrease. In other words, it's going to require a large amount of force to move a heavier object than a lighter object. Let's see how this law works. Imagine there's a 20-pound box sitting on the floor. If you push the box with your hands, it will slide across the floor at a certain speed. And if you ask your friend to help you and both of you push the box, it will slide much faster. With 2 of you moving it, the amount of force has increased, causing the acceleration to also increase. Now, if you both push a larger box weighing 40 pounds using the same amount of force, the box won't move as fast as a 20-pound box. But why did it slow down? There are still 2 people pushing it. In this case, the mass of the box has increased and the force is still the same, so the acceleration has decreased. Let's calculate how much force is required to accelerate a 40-pound box at 4 meters per second squared. We can use the formula F is equal to ma, where F is the force, m is the mass, and a is the acceleration. This is the formula for Newton's second law. The unit of force is Newton, abbreviated by letter N. 1 Newton, or N, is equivalent to kilogram times meter per second squared. When solving for acceleration, the formula is A is equal to F divided by m. And for solving for the value of mass, The formula is m is equal to F over A. Newton's third law of motion. Newton's third law states that for every force, there will always be an equal and opposite force. It means that when object exerts a force in the second object, the second object will exert an equal and opposite force back against the first one. Let's look at this law in action so that we can better understand it. Let's consider two tennis balls sitting on the table. One ball in one end of the table and one on the other end. When you and your friend use the exact same amount of force and push both balls towards one another, they will roll across the table, striking one another. After they collide, the balls will bounce off one another and move in opposite directions with the same speed. We can also see the third law in action. If we throw a ball against a wall, the ball will exert a force on the wall, and the wall will also exert an equal force against the ball. Another example can be seen in a takeoff of a rocket or a space shuttle. As it lifts off, the rocket engine expels gas at a high velocity towards the ground. The Earth will exert an equal but opposite force on the gas, and the rocket will accelerate into space the opposite direction of the expelled gases. The flight of birds across the sky and the rowing of a boat in a lake are all examples of Newton's third law of motion.